when we add them up, it should still be a negative number. So that's when I realized it had to be a mistake. All right, any questions about that? Let's take out our note packet. I think we're on number 3. We got our first word problems. So now we're going to talk about some word problems, arithmetic word problems. And then after today, I mean, you should have the majority of homework 23 finished. We'll go over it tomorrow at the beginning of class, and then we'll keep working. I'm trying to finish the unit by Friday so that you all can have more time to review for the last quiz of the year, and then we'll get ready for the final. Let's look at number 3. It says, consider a different seating arrangement for the auditorium from Agile Mind. Agile Mind is an old book we used to have. We just haven't rewritten this question. All right, so we have an auditorium. In this auditorium, the first row is called row A, and it has 15 seats. So remember, that represents row 1, so that would be T1. T1 is 15. That's how many seats we have in the first row. Each of the rows behind row A is labeled alphabetically, so then it would be A, then B, then C, then D, etc. And they have 5 more seats than the row in front of it. So this 5 would represent our common difference. Let's go ahead and write the rule. So T sub n equals how many seats are in the first row plus 5 times n minus 1. Now use the rule that we just wrote in part A. Figure out how many seats would be in the 18th row. So to find T18, that means that n is 18. Take a minute, type that in, and see what you get. Thank you for making sure we're safe. You got to keep us safe. Okay. Yeah. Don't let everybody in here. So how many seats did you come up with for the 18th row? What'd you come up with? 100. So there are 100 seats in row 18. So now part C says, what is the total? That means I have to find the sum. I'm using the sum formula from rows A through F. So first of all, if I count alphabetically from A to F, how many letters would that be? 6 letters. Does everybody agree? So that means that there will be 6 rows. So n equals 6. So I need to know how many seats are in row 1, which we know is 15. But if I'm trying to find the sum of the first 6 rows, I also need to know T6. So go ahead, use your calculator. Hi, how are you? I'm right here. Thank you so much. I appreciate it. So use this general rule right here and figure out how many seats would be in row 6. So we're going to take 15 plus 5, and then we're going to type in 6 because we're doing row F. Row F is the 6th row. Type that in your calculator. And you should get 40. Who got 40? So now let's find the sum of all the first 6 rows. So that would be 6 over 2 multiplied by how many seats are in row A plus how many seats are in row F. Go ahead, type that up, and that is your sum. And that's it. That is all that is to that. All right, I want you to look at question 4. We got a concert hall, and I want you to try to write a rule for part A. Read question 4 Try to write your rule. So we need to know two things. We need to know how many are in the first row and what's the common difference. So row 1 has 25 seats and they're adding one more seat. So that means the common difference is 1. Raise your hand if you had that. All right, it's asking for the total number of seats in the concert hall. How many rows are in this concert hall in all? 32. So we need to know T32. Use that rule to find T32. So who got 56 for row 32? So we need to find the sum. So the sum of all 32 rows will be 32 over 2. Multiply that by how many seats are in the first row, which we said was 25, plus how many seats are in the last row, which is 56. Anybody else get that answer? 1,296. All right, but now it says that we're going to add to this concert hall. They're going to add 12 more seats, 12 more rows. All right, so if I'm adding 12 more rows, that means I used to have 32 rows.
Now you got 44.
I have 44 rows. So we need to figure out what my new capacity will be. So if we're keeping the same general rule, what would be your first step? What would you find first if this was a test question? T44. Go ahead and find T44. So who got 68 seats in the 44th row? All right, so now that we know that, let's find our new capacity. So the sum of all 44 rows would be, because there's now 44 rows, we're going to take 44 divided by 2, multiply that by 25 plus 68. But that didn't answer the question, because the question is saying how many additional seats, and we didn't answer that question. So how do I figure out the number of additional seats? Subtract. So subtract the new total, take your new total, and subtract from that the old total. And that means we have 750 additional seats. All right, so go to the next page. We're going to do number 5. We're not doing number 6. I want you to try. I'm going to give yourself a couple of minutes and try to answer number 5. It says the corner section of a football stadium has 15 seats in the first row and 40 rows in all. Each successive row contains 2 additional seats. And we want to know how many total seats are in the section. So try to do number 5. And then we'll work through it together in a few minutes. Am I going too fast for you? Oh, I'll go back. It's okay. All right. All right, raise your hand if you have that for the general rule. That's just a general rule. So that would be my first step. And then what did you do next? What did you figure out? What would you say? Oh, anybody? Daniel? Yep, find T40, yeah. Because we know how many were in the first row. We got to figure out how many are in the 40th row. So find T40. And you get 93. Who had 93 seats in the row 40? And now to find the capacity, we need to find the sum. Yep. So it would be 40 over 2 because that's how many rows we have. So it would be 40 over 2 and then 15 plus the 93. So what you think about the arithmetic sums?
It's not really hard.
It's not hard? I'm always nervous to say that because every time I say that, then I feel like I jinx.
No, the word problem
Stuff.
is kind of weird.
They are? Okay.
It's just like whatever.
Yeah. Yeah, I feel like that too. I do. I feel like that too. We usually try to do the easiest thing last, but I don't, All right, so now we're going to start the next sequence, and that's geometric. Homework 24 is due next week on Tuesday. We're going to skip over question 6 if you didn't figure that out. Homework 24 is over geometric sequences, and that's due next Tuesday, December 10th. All right, so now let's start filling in what we know about geometric. So what a geometric sequence is, instead of repeated addition, it is repeated multiplication. So if we look at these numbers, what are we multiplying by? 2. So what would be the next number after 16? 32. And then after 32? Then after 64? And after 128? 256. This is how you write a general rule if it's repeated multiplication. We still have T1. T1 is still your first term. And then we have what we call R, which is what we're multiplying by. It stands for common ratio. So for this example, the common ratio would be 2 because I'm multiplying by 2. And then just like in the last example with arithmetic, N, that's how many terms. Now, I will say, I'll give you a minute to copy this down. Most of the time, it's really easy to figure out what that common ratio is. Okay, this one, it was pretty easy because we were just multiplying by 2. But sometimes the common multiplier could be a fraction or a decimal, and that could be a little trickier to find. So if you're ever not sure, here is the formula to help you find your multiplier. You just take the second term and divide that by the first term. So if you can't figure it out, because you will have some multipliers that might be 0.6. So you might have a multiplier that's like 1.3 or 1.6, and that's harder to figure out without a calculator. So that is a formula that you can use to find what the multiplier is. Geometric means multiplication. Arithmetic means addition. Now, the other thing that I want you to notice in this, notice that in our general rule, we have an exponent. That's how we can tell that it's geometric, is because we have this exponent. Because how do you show repeated multiplication? We do that with an exponent. So I'll give you some time to go ahead and fill that out, and then we will do a few more, and then we will end there. Any questions? Anybody need more time to copy this down? All right, so let's look at these. First example. So we're looking at these two examples. What kind of sequence do you think we have here? Geometric. We went from 1 to 3, 3 to 9, 9 to 27. So this would be a geometric. And if it's a geometric, we have a common ratio. What am I multiplying by? 3. And that would be 3. And if you couldn't figure it out, you would just take the second number and divide it by the first number. So R would equal 3 divided by 1. What about question B? What kind of sequence does that appear to be? Yep, arithmetic, arithmetic. And arithmetic has a common difference. So I'm going to cross out. For geometric, we don't have a common difference. We have a common ratio. For arithmetic, we have a common difference. We don't have a common ratio. What is my common difference for question B? -7. Good job. So now let's go ahead and figure out in this next example. It already told us that it is a geometric sequence. If you're not sure what your common ratio is, again, you can always take the second number and divide it by the first number. if you're not sure. There's nothing wrong with checking it to be sure. But if you do that, you should get 4. Who got 4? So that means I'm multiplying by 4. So that's my common ratio. So let's go ahead and find the next 4 numbers. So we got 0.5 times 4 is 2. 2 times 4 is 8. What's 8 times 4? 32. Ooh, 32 times 4. 128 times 4. And 512 times 4. Okay. Notice how for geometric the numbers get big pretty fast because it's exponential. It has an exponent, so it rises. So let's go ahead and write our rule. So let me go back to what you wrote at the top. In order to write the rule, we're substituting in 2 things. We're substituting in T1 and we're substituting in R. That's how we write our rule. So for this one, the first term, so T sub n equals the first number, which is 0.5. Now, I generally always put my R value in parentheses. You don't have to do that. Like, you could just put a times 4. I don't like that, though. I always put it in parentheses. I just think it looks cleaner. It's part of my OCD. And that's to the power of n minus 1. So we're going to get a pretty big number. But using this rule, find the 14th term. So it would be 0.5 times 4, and then it would be to the power of 14 minus 1, which hopefully is actually a number that we can, it might put it in scientific notation. No, it didn't. Okay, it's a big number. That's a lot of money. I'm gonna write it though. So we got 3, 3, 5, 5, 4, 4, 3, 2. So what's that? 33,554,432. Ooh, that's a lot of money right there. Any questions about that? All right, one more, and we will end there. Let's go to question B on the next page. Oops. Question B. All right, so we got to figure out the rule, which means you have to find the common ratio. This time you can write it as a fraction or a decimal. All right, I don't have a preference. If you're not sure, take the second number divided by the first number. So I think this time you get 1/4 or 0.25. Who got that? Again, I have no preference. You can write that as a fraction or you can write it as a decimal. So let's go ahead and do that. Keep multiplying by 0.25 to get the next 4 numbers. Take 64 times 0.25 and just keep going. Get the next 4 numbers. Who had that for the next 4 numbers? All right, let's write the rule. T sub n equals the first number, which is 1,024. Again, I like to use parentheses for my common ratio. And I'm going to write it as a fraction. Fraction or decimal is the same thing. 1/4 is the same thing as 25 cents. And now use that rule to find the 14th term. Substitute in the 14. And you get a really small number. Hi, 1 second. Like just 1 minute. Okay. Okay. And then it's 1,524 259. Whew, it's a big number. Well, no, that's a small number I meant to say. Oh, wait, that don't look like a 9. Let me fix that. Okay, any questions so far? All right, this is our good stopping point. We will pick up at number 3 tomorrow.